Hello everyone, this video covers section 7.4, which is the last integration technique called partial fractions, and then 7.5, in which is just a combination of all the integration techniques. So partial fractions is something that you saw in college algebra or just algebra 2. So remember, you want to add fractions. You find the LCD. So the LCD in this case is x plus 1. That's x minus 2. And then remember to add fractions. You technically multiply by whatever it would make. We will give you the LCD. In this case, it will be x minus 2. And this one will be x plus 1. And then from here, you will end up with 2x minus 2 plus 3x plus 1 divided by the LCD, which is x plus 1 times x minus 2. Then you simplify and you end up with 5x minus 1 over x squared minus x minus 2. Okay? Now that's adding fractions, that's not partial fractions. Partial fractions is you have this, where did this came from? So you had to go backwards and you will end up with this. And in essence, what the partial fraction is going to do, and this can be pretty annoying or pretty long depending on how many factors you have. So you're gonna need to find values A and B so that when you combine it, it will give you this. And obviously, if we go backwards, you will gonna end up A to be 2 and B to be 3. Why do we need partial fractions? Well, to integrate this, which is what we have right now, you can see could be pretty annoying, or what you're not even sure how to approach it at the beginning. But if you use partial fractions, we know that this is equivalent to this, and that will make solving the problem pretty easily. So this is what I mean. By partial fractions, which we haven't done it because we just know right now that this is equals to this. So that means you can break this into two pieces. This will be 2 over x plus 1 dx plus 3 over x minus 2 dx. And notice that to integrate this, it will be very easy. This is the integral of dx over x plus 1. This will be 3 dx over x minus 2. Partial fractions is when I use a lot the basic integral, which I told you before, du over u, which is ln of u plus c. So in this case, this will be 2 ln of x plus 1 plus 3 ln of x minus 2 plus some constant. And we're going to use these rules a lot too from pre-calculus. Remember that ln of a over b is equals to ln of a minus ln of b. And then ln of a times b is equals to ln of a plus ln of b. So therefore you can go from here to here and you can go backwards. Now, whenever you have everything in terms of ln, you should change the constant also in terms of ln, because ln of a constant is just a constant. So now if we use these rules, there is one more, ln of a to the r equals to r ln a. So we use these rules, you can rewrite this as a single integral. This will be ln of x plus 1 square times x minus 2 cube, and then times the constant. Now, if you get this far, this is technically correct, but the answer in the back of the book most likely will look like this. Okay? So this problem shows you why partial fractions are needed, because if you try to do this, notice the substitution won't do it. The trig integral may not do it. Integration by parts may not do it. So therefore, the last method is the partial fractions. So you will change this into 2 fractions. And usually you're going to use this, not all the time. And you can see how easy it was once you break it into 2 pieces. Okay. So the the annoying part is to get the partial fractions, which is how you go from here to here. So we'll do a few examples like that right now. All right, so this is where we have the x minus 4 over x minus 3 times x minus 2. So the first thing you need to do is factor this. So this factors to that. So then based on what I told you earlier, then you need to figure out the value for A and the value for B, so that it will give you exactly the original fraction you have. Okay. So the question is pretty much what's the value for A and B. So this is why you do A times x minus 2, which is just adding fractions, plus B times x minus 3 has to be equals to x minus 4. Now, if you only have linear factors like this is actually pretty fast, because you can cheat, and I'll tell you what I cheat. I'll tell you what I mean by cheating. If this involves quadratic terms, then or more than 3, this can start getting pretty long. It's not hard; it just takes a while. So, but this is what I mean by cheating. If you select the value for x to be 2, and the only reason why we're doing that, obviously, is because notice that 2 minus 2 is 0. If we do that, you will have a times 0 plus b times negative 1, and here you will have 2 minus 4. So this implies that minus b is equals to minus 2, which means that b is 2. So you can see it's pretty easy to solve it this way. Obviously, the next value you should pick is equals to 3. So if x is 3, then you will have a times 3 minus 2 plus b times 0, and it will be 3 minus 4, which you can see that a is equals to negative 1. Okay, so again, this was pretty easy, pretty fast, because these are linear factors and you only have two of them, and you should definitely do this every time you can. All right, so therefore the integral that we have, the original integral, is going to become this now. So we're going to forget about the limits of integration for now. So this is going to be the integral of a, but notice that a is equals to negative 1. So this will be minus the x over x minus 3 plus b, which was 2 over x minus 2. And like I said, these are very easy integrals. This will be minus the x over x minus 3, and then 2 the x over x minus 2. So this will be minus ln of x minus 3, and this will be plus 2 ln of x minus 2, and then ln of c. You can always do this for a constant, and therefore this will be now, since this is negative, technically you can write it as a division of logs. So this will be ln of x minus 2 squared over x minus 3 times the constant in there. Or if you just want to write this as a constant by itself, this will be ln of x minus 2 squared over x minus 3, and then plus c. Both of the answers are correct. Okay. Right, let's try the next one. There is a typo here. This should be xq. And if we factor this will be x times x squared plus 3. Notice how this is a quadratic term now. And quadratic terms take a lot longer to get the partial fractions. But in either case, you have two factors, and this is what you're going to have. You're going to have a over x, which relates to this one, plus bx plus c. So every time you have a quadratic term that you cannot factor, you're going to need two constants. And on the bottom, this is obviously x squared plus 3. And obviously, you need to get the original equation. This is what you're trying to get. Okay, so this will be x cubed plus 3x. Okay. So then we do the typical adding of fractions. So this will be a times x squared plus 3. And then this will be bx plus c times x. And the whole thing has to be x squared minus x minus 6. Okay? And we should cheat as much as you can here. And by that, I mean use whatever values you can. Notice that here, there's not much you can use except for maybe x equals to 0. If x is 0, this will be a times 3. And then this will be b times 0 plus c times 0. And then this will be 0 squared minus 0 minus 6. So that means 3a equals to minus 6. Or a equals to negative 2. Okay? But now you cannot use any other values that will cancel any of this. So when that happens, you're going to have no choice but to distribute this. And this is what I mean by distribute. If you distribute these numbers, you have ax squared plus 3a plus bx squared plus cx. And this has to equals to x squared minus x minus 6. And this is the part that can take a while. Sometimes you may even have to solve a system of equations. That will not be the case for the test because it takes too long. But what you have to do is just match the coefficients or the exponents. So notice that if we focus on x squared, so you have x squared here, and you have x squared here, and notice you have x squared there. So since both of them have to be equal to each other, the coefficients have to match. So that implies that a plus b has to equals to 1. But you already know what a is. A is negative 2 from here. So that means that negative 2 plus b has to be equals to 1, or b has to be equals to 3. Okay? And now you have a, you have b, you still need to figure out c. And for c, notice that c, you only have one here with x. So if you match the coefficients, that one is actually not that bad. This automatically implies that c has to be negative 1. So that one was easy. So then once you do all of this, which you should do all of this on the side, so then the integral can be broken into these two parts. In this case, it's actually going to be 3, but first is 2. A, remember, is negative 2, so this is negative 2 over x dx, plus b, which is 3x minus 1, so this is ax plus b, I'm sorry, bx plus c, divided by x squared plus 1 dx. And you can break this into now 3 intervals. This will be minus 2 dx over x. This will be 3 x over x squared plus 1. And then minus the x over x squared plus 1. This is actually x plus 3 now 1. Okay. And this one is easy. We have done it 3 or 4 times in the previous example. This is just minus 2 ln of x. Now notice that for this one you can just use a substitution. For that one you can say u is x squared plus 3. So the u is 2x. The x, so therefore this is the 3 you have there. You need 1/2. And then this will be ln of x squared plus 3. You do substitution. And the last one is just tangent inverse. But because of the 3 here, you just have to modify a little bit. So this is 1 over the square root of 3 times tangent inverse of x over radical 3. Remember that in general, just for this, And you can get this using a trig substitution. So you should check this by yourselves. The integral of x squared, the integral of the x over x squared plus a squared equals to 1 over a tangent inverse of x over a plus c. So if you look the similarity between this one and this one, well, from here we have that a is equals to, or a squared is equals to 3. That means a is the square root of 3. So if you plug this into here and we put it in there, that's how we get the answer. And that's it for that one. All right, so let's try one more, which is a little longer. Notice here you can factor the x squared, and this is x squared plus 6. And notice that now you have two quadratic terms. So therefore the partial fractions are going to be as follows: a over x plus b over x squared, and then this is cx plus d over x squared plus 6, and all of this has to equal to x cubed plus 6x minus 2 divided by the LCD. Okay. So also notice that you can rewrite this in this way, and it's exactly the same thing. You could just write this as ax plus b over x squared, and notice how it will give you exactly this. Okay. All right, so if we do the same thing we've been doing, this will be a, you need a x, and then x squared plus 6. The b only needs the x squared plus 6, and then the cx plus d needs the x squared, and all of this has to equal to x cubed plus 6x minus 2. Again, all of this is algebra. Now in this case, having I guess the only cheating you can do, if x is equals to 0, then the first one will be 0, then it will be 6b plus 0, and this has to equals to 0 cubed plus 6 times 0 minus 2, which means that b has to be equals to minus 2 over 6, or minus 1/3. But after that, you had to just distribute this, because you cannot plug any more values. So notice that this will give you ax cubed plus 6xa, or a6x, plus bx squared plus 6x, and then plus cx cubed plus dx squared, and obviously all of this has to equal to this, like I just mentioned. Okay. Right, so now you just have to match the coefficients. So let's start with the q, and notice that for the q, this is a 1, and for the q, you have q in there and q in there. So that means that a plus c has to equal to 1. Then if you look to the x squared, you have this one and this one. So that means that b plus d has to equal to 0, because you notice there is no x squared here. So this means that b has to equal to minus d, or the other way around, minus b is equals to d. So that means that d, since you already know b, it will be equals to minus 1/3, so it's equals to 1/3. Okay. And then if you look to the x's, notice that for x, you have x there. So that means that 6a has to equals to 6, which means that a is equals to 1. So that was easy. From here, since a is equals to 1, that means that c has to be 0. You have no choice. Okay. Or this implies that c is 0. So therefore, for the integral, this is what you have. The integral is going to be dx over x plus or minus, it's actually minus 1/3 the integral of the x over x squared, and then plus 1/3 the integral of the x over x squared plus 6. This one is well known. Remember that this is ln of x. The integral of this is actually minus 1 over x. Okay. And then this is 1/3. This is the integral that we just did in the last example. Notice that the a squared is equals to 6. That means a is the square root of 6. So this will be 1 over the square root of 6 tangent inverse of x divided by the square root of 6 plus c. And then just simplify everything. So this will be ln of x plus 1 over 3x plus 1 over 3 radical 6 tangent inverse of x over radical 6. And that's it. Now, if the degree of the top is bigger than the degree on the bottom, or the same, they're the same, then partial fractions don't work like that. You need to make sure that the one on the top is less than the bottom. So if that's the case, you're gonna have to do long division first. So you have x to the fifth. You don't have any x squared. You don't have any x cubed. You don't have any x squared. Sorry, x to the fourth first. X cubed, x squared. And then this is x minus 1. And you are dividing everything by x cubed plus 1. Just when you thought you would never have to do long division again. So then this will be x squared. So this will give you x cubed. And then plus x squared. And remember that when you do long division, you have to change the sign. So you'll end up with minus x squared plus x minus 1. So this is the remainder. Okay. And also notice the x cubed plus 1. In case you haven't realized that, if you factor this, this is a sum of cubes. This is x squared plus 1 times x squared minus x plus 1. Okay, just for the record. And conveniently, this one, notice that if you factor the minus sign out, it will be equals to exactly that. Okay. So you need to use whatever to simplify this as much as possible, but this is what I have so far. So the integral, if you just divide, because we haven't done any partial fractions or anything like that, this will be equals to x squared, which is this, okay, plus the remainder. Well, the remainder is minus x squared minus x plus 1 divided by x cubed. But x cubed we say was x plus 1, x squared minus x plus 1. All right, so you can see that these two cancel. So this will be x squared dx minus dx over x plus 1. And this will be very easy to integrate. This is x cubed over 3. And then minus ln of x plus 1 plus c. That's it. So again, you have to do this every time where the degree of the top is bigger or equal to the degree of the bottom. The partial fractions will not work until you do this long division first. Okay. We actually did that before with a trick for this problem. So remember, you wanted to integrate x squared over x squared plus 1. We did the trick of adding and subtracting 1, but let's say that you didn't know that, so you had to do this x squared plus 0x plus 0 divided by x squared plus 1. And this one will give you 1. This is x squared plus 1. Then you change the sign. So it will give you 0. This is minus 1. So then this one will be 1 minus 1 over x squared plus 1. And remember, the integral of this is x, and the integral of this one is tangent inverse. So we did this one a couple times before. So now this is from the point of view of partial fractions. Okay. Now the next problem, this is a little more tricky because the way it is, you cannot really do much. So you have to do a substitution. The substitution is going to change it into partial fractions. Then you have to do the partial fraction. So this problem is a lot longer than what it looks. So this is what I mean. You're going to start with the following substitution. Let u to be equals to x to the 1/3. So that means that x is equals to uq. Okay, basic algebra. So that means that the x is equals to 3u squared du. Okay, basic calculus. So then we are going to rewrite the integral. Okay, so I is going to be the integral of dx, which is 3u squared du, which is this part. And then this will be now u plus 1. Now, like I just told you in the previous example, notice that this is bigger than the bottom, so you have to do long division. So first, just take the 3 out before we do the long division. And this is what we're trying to integrate. So you do the long division, this will be u squared plus 0u plus 0. And we're dividing this by u plus 1. So you need a u, so this will give you u squared plus u. Change the sign, so it will give you 0 minus u plus 0. And then you can do this one more time. So you do minus 1. So this will give you minus u minus 1. Again, change the sign, and this will give you 1. So therefore, you can rewrite this as 3. The integral of u minus 1 du, which is this part, and then finally the remainder, which is the integral of du over u plus 1. Okay. And these integrals are pretty easy to do, so this will be 3. The integral of u is u squared over 2 minus u, and then the integral of this one will be ln of u plus 1, and the whole thing plus c. And then just change back from x to u. Remember that u was equals to x to the 1/3. Okay, don't forget that. So then this will be 3 halves, and then this will be x to the 2/3 minus 3 x to the 1/3, then plus 3 ln of x to the 1/3 plus 1, and then finally plus c. Okay. So this is a typical problem where any of the previous methods will not work, like the ones from 7.1, 2, and 3 will not work here. So you have to do a substitution, and then you use partial fractions to do it. Once you get to this point, in theory, you can actually also use trig substitution if you want to. Okay? So once you do substitution, you can use other methods. All right, this problem is very, very similar to the previous one. You have to do substitution first. So let's say that u is equals to e to the x. So the u is also e to the x dx, which means the x is equals to the u over e to the x. But notice that u to the x is the same thing. So notice that e to the x is the same thing as u. So therefore, you can say that the x is just the u over u. So this is key to what we're doing. So therefore, from here, the integral now is going to be dx. You only need one, which we say is the u over u. So that's the dx. And then times 1 over e to the x, which we call the u, plus 1. So this is what we're trying to integrate. Or this will be du over u times u plus 1. Okay? So then we will do the partial fractions. So remember, you need a over u plus b over u plus 1. And this has to equal to just 1 over u plus 1. So this is like the very few problems we did today. This one you can do the cheating technique. I told you every time you have just linear equations, the cheating part works pretty easily. So here you pick u to be 0, well, you're going to have a equals to 1. If you pick u to be negative 1, then you're going to have minus b equals to 1, which means b is negative 1. Okay? And therefore, from here, this becomes the integral of a, which will be du over u, minus b, which will be du over u plus 1. The integral of this one is ln u. The integral of this one is ln u plus 1. And then you can say ln of c for the constant, or just c. And then you have to change back to u. Remember, u was equals to e to the x. And this, therefore, is e to the x plus 1. And this is ln of c. And you can rewrite everything as a single log as follows: ln of c e to the x over e to the x plus 1. And that's it. All right, so this is the last technique. In the next few problems, we're going to go to 7.5. And 7.5 is just a combination of everything we done before, which is integration by parts, partial fractions, trig integrals, and trig substitution. So you look through the problem, and then you have to decide which will be the best way to go. Okay? All right, so let's start with this problem. Before we do this, recall we have used this multiple times. The sine of 2 theta is equals to 2 sine theta cosine theta, which means that sine theta cosine theta has to be equals to sine 2 theta over 2. Okay? We're going to use that right now to make our life easier. So my point is that this integral can be rewritten as just x times sine of 2x over 2, or you can just put the 1/2 in front, and it will be x times sine of 2x dx. Notice that for something like this, the obvious method to use, it will be integration by parts. So u will be x, dv will be sine 2x, so du will be dx, and b will be 1/2 minus 1/2. No, just 1/2 cosine 2x. No, it has to be minus, because the derivative cosine is minus sine. Okay. So then, by integration by parts, it should be ub, which will be minus 1/2 x cosine 2x, then minus b du. Or all of this is multiplied by 1/2. Let me make sure I get that. So minus b du, where du is just the x. So then this will be equals to 1/2 times minus 1/2 x cosine 2x minus 1/2. Now the integral of cosine 2x is 1/2 sine 2x, and all of this plus c. So then if you distribute the 1/2, it will give you minus 1/4 x cosine 2x minus 1/8 sine 2x plus c. And that's it. All right, this next one looks actually pretty tricky, but it's pretty easy as long as you know the right substitution. So here let u equals to x to the p. That means the u will be p x to the p minus 1 dx. And the key to everything is how you write this part. Notice that this is the same thing as p x to the p over x dx. So this is crucial to the whole thing. So therefore from here you can just rewrite this as u. Notice that this is actually the du has the whole thing here, so this is du, and then on the bottom there will be u squared plus 1. You need to cancel the p that is right here, so you put 1 over p in front, because remember the p is a constant. You should check that this makes sense. So notice that if u is equals to x to the p, well, this implies that u squared is equals to xp squared, which is clearly x to the 2p. Okay, so you can see that this is equals to this. But now this is one of the basic integrals that you should have used hundreds of times by now. This is just tangent inverse of p plus c, and p, remember, was equals to tangent inverse of u, where u is equals to x to the p, and that's it. So very, very, very simple. Okay. All right, let's go to the next one. So here you had to do a substitution first, and then you decide which method to use. The substitution should be the following: u equals to ln x. So notice that the u is just the x over x, and it will give you this part right here. So notice that this is the x. So if we play it in here, this will give you the u, the top, du, and on the bottom this will be 1 plus u squared. Okay. So for this one you can just do now regular substitution. So let's say that w is equals to 1 plus u squared. So again, this is regular substitution from calculus 1. Okay. So therefore dw will be 2 u du. So therefore from here this becomes the integral of 1/2 du, or 1/2 the integral of, not du, it should be dw over w to the 1/2, or the square root of w. So you can rewrite this as 1/2 the integral of u w, so to the negative 1/2 dw, and then if you integrate this, you will get the following. This is equals to 1/2 w to the minus, remember you need to do minus 1/2 plus 1, which will give you 1/2, so it will be 1/2 times 2 over 1 plus c. So therefore this is 1/2. The 1/2 actually cancel, so there is no half anymore. So this is just w to the 1/2, which remember is the square root. So you will end up with the square root of w plus c, or the square root of u, by u, remember, was equals to w was 1 plus u squared, by u was equals to ln, so this is the square root of 1 plus ln of x squared plus c. Okay. Note, and you should give it a try, you can also use trig substitution to solve this problem. The next example, I think I asked you this on the quiz, but just in case. So this is just a basic substitution. So here just let u equals to 1 over x, which is the same thing as x to the negative 1. So that means the u will be minus x to the negative 2, which is negative, the x, which is negative the x over x squared, which notice you already have it there. So therefore this will be minus e to the u du, and this is quite possibly the easiest integral we done before. This will be minus e to the u plus c. So it will be minus e to the 1 over x plus c. And that's it. Now, number 5 requires an identity that we haven't talked about it, so we'll skip it for now, and I'll just go over in class. But it's just identity from trigonometry, but we haven't used it yet. It's actually pretty simple, but we'll use it, and I'll just go over in class. All right, so now let's go to the next one. This is very similar to the last problems we did in section 7.4. So here let u equals to 1 plus e to the x. So that means that u squared is equals to 1 plus e to the x. And then if you take the derivative, that means that 2u du is equals to e to the x dx. And if we solve for d to the x, this will give you 2u du over e to the x. But notice from here that e to the x is the same thing as u squared minus 1. Okay? So therefore this will be 2u du over u squared minus 1. Now, it looks like we made the problem worse, and we kind of did, but now we'll be able to solve it. Like, we don't have any derivatives or any functions that the derivative will give you this. So therefore, we had to find a different way. Notice that we call this u, so it will be u, and the x was all of this. So therefore, the x is 2u over u squared minus 1 dx, which this is what we end up with, 2 u squared over u squared minus 1 dx. This should be du. Okay. And now you can use partial fractions. Before we do that, notice that they have the same degree. So you have to do long division. So you do u squared plus 0u plus 0 divided by u squared minus 1. Well, notice that you need a 1 here. This will give you u squared minus 1. If you change the sign, this will give you 1. So therefore, this will be twice the integral of 1 du plus the integral of du over u squared minus 1. Well, clearly, the first one is straightforward. This will be just 2u plus this one you have to use partial fractions, and you need to break down 1 over u squared minus 1 as a over u minus 1 plus b over u plus 1. And you should check, because we have done this multiple times now, that a is equals to 1/2 and b is equals to negative 1/2. It should be very easy to check this. Okay, so therefore this becomes 1/2 the integral of the u over u plus 1, minus 1, and then minus 1/2 the integral of the u over u plus 1. Okay, and as you already know, these are very easy to integrate. So this will be 2u plus 1/2 ln of u minus 1 minus 1/2 of ln of u plus 1. Okay, obviously everything plus c, and then you multiply everything down. This will be just 2u plus ln of u minus 1 over u plus 1 plus c, and then you have to change back to what u was. Remember, u was 1 plus e to the x. Okay, so then this will be on the top, the square root of 1 plus e to the x minus 1, the bottom 1 plus e to the x plus 1, the whole thing plus c. And that's it. By the way, you can also use trig substitution to solve this problem once you get to this point, though. And you should give it a try to make sure you get the the same thing. All right, so finally, for this one, notice that you can break this into two integrals. This will be x over 1 minus x squared dx, and the other one is sine inverse x over 1 minus x squared dx. And this one you can use strict substitution, but there is no need to do that. For this part, you can just say u is equals to 1 minus x squared. So the u will be minus 2x dx. So therefore, the first integral is going to be minus 1/2 du over the square root of u. And for the second one, here you can say u is equals to sine inverse. And du is technically the x over 1 minus x squared, which is what you already have there. So the second integral is going to be, well, maybe we should call this a different variable. So let me call this one w instead of u. Let's say this is w. So then this will be w dw. So we already know the integral of this one is minus 1/2 u to the 1/2 times 2 over 1. And it will be w squared over 2 plus c. So therefore this is minus the square root of u, which u was 1 minus x squared, and this is 1/2 sine inverse x squared plus c. And again, just give it a try, make sure that that's the case, and that's it.